So today's lesson is on exponents. So this activity is called the Genie's offer. This might look familiar to some of you. We did discuss this some weeks before our break started. But I wanted to revisit this activity because I just think it's a really awesome way to illustrate what exponents mean. So let's read the instructions together. So imagine that you find a brass bottle that looks really old, and when you rub some dirt off of it, a genie appears, and the genie offers you a reward. You need to choose one. You can either have $50,000 or a magical $1 coin, just $1. And that coin will turn into 2 coins on the first day, and the 2 coins will turn into 4 coins on the second day, and the 4 coins will double to 8 coins on the third day. And the genie explains that that doubling will continue for 28 days. Okay? So, most people at the time said they wanted $50,000. Kind of makes sense, right? So this coin's doubling, so it's a magic coin, pretty cool. But it's only doubling for 28 days. So that's not that long. Like if it doubled forever, obviously you would want that one. But 28 days, doesn't really seem that long. So, let's look at number 1. So the number of coins on the third day would be 2 times 2 times 2. We want to write an equivalent expression using exponents. So this is 2 times 2 times 2, which is 2 to the third power. All right, or 2 cubed, we could also say that. So once again, this is an exponent, that tiny little number in the corner, and then we call the big number that the exponent is attached to the base. And it's important for us to note the definition of exponents. So multiplication is repeated addition. Exponents are repeated multiplication. So 2 times itself 3 times is the same thing as 2 to the third power. And as an answer, if we actually solve that, 2 times 2 is 4. Bring down the next 2. 4 times 2 is 8. Okay? So that means on the third day, we would have $8, which was also mentioned in the problem. Okay. So, if this is the amount of money on the third day, then what do 2 to the 5th and 2 to the 6th represent? Well, if this is day 3, then 2 to the 5th is the 5th day, and 2 to the 6th is the 6th day. Okay, it says, without a calculator, find these values. So, we can always take this exponent and write it in expanded form. So this is 2 times itself 5 times. 2 times 2 times 2 times 2 times 2. And let's also take a note in your notebook that this is called expanded form. Okay, taking that exponent. So we can go from exponential form which is the form that has an exponent, and then expanded form is the one that shows that repeated multiplication. And so we can do this same kind of work that we did up here for this. So 2 times 2 is 4. And now I've got to bring down the next 2 times 2 more is 8. Bring down the next 2 would be 16. And then multiply that by our final 2 and 32. So on the fifth day, we would have $32. And so 2 to the 6th power is 2 times 2 times 2 times 2 times 2 times 2. So 6 2's. We could do this again to get our answer, or we already knew that 2 to the 5th power was 32. So 2 to the 6th power is just one more 2, and that's 64. Okay, we just had to multiply our answer from before. If 2 to the 5th power is 32, then just multiplying it by 2 one more time would get us 2 to the 6th power, which is $64. So, number 3, how many days would it take the magical coin to exceed $50,000? So, we'll start at 64, which is 2 to the 6th. Okay, so that means on the 7th day, we'd be at $128 times 2 more. On the 8th day, $256. 9th day, 512. 10th day, 1024. 11th day, 12th day, 13th, 14th day, 15th day, and by the 16th day, we would already be at 65,000. So 15,000 more dollars than if we would have just taken that 50K from the get-go. So it would take 16 days. To exceed, meaning be more than 50,000. So at this point, kind of thinking that maybe should have taken that coin. And then it says, will the value of the magical coin go beyond $1 million within 28 days? So this is us at 16 days, times 2 more, 17 days, 18, 19, 20. So on the 20th day, we will already be at over $1 million. All right? And then we still would have 8 more days to go. 21st day, 22nd, 23rd, 24th, 25th, 26th day, we're at 60 million. 27th day, 134 million. And on the 28th day, we would be at $268,435,456 by the end of that 28 days. That is just showing us how fast exponential growth increases numbers, right? That repeated multiplication builds like crazy. So you're thinking a dollar coin just doubling for 28 days. At first, you might not think it's going to get that big, but as we can see, it gets real big real quick. So to all the people who chose the dollar coin, good choice. All right. And then for the rest of this video, we're going to just work on this problem. So making 81. So it says we've got 4 expressions. All but one of them equals 16. So we need to find the one that is not equal to 16. All right, so let's look here. So this is 2 to the 3rd power times 2. So I'm going to write this in expanded form. Here's my 2 to the 3rd power, 2 times 2 times 2. And then there was one more, so I added it. Because this is technically 2 to the 4th power. And 2 times 2 is 4. 2 times 2 is 4. Multiply those together, 16. All right, down below, 4 squared, expanded form, 4 times 4, 16. All right, 2 to the 5th power over 2. So we need to use PEMDAS, our order of operations here. So we know fractions are division, so there's going to be division at play, but we also have an exponent here. So the E in our order of operations stands for exponent, so we do have to solve the exponent first. So expanded form would look like this. 2 to the 5th power over 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this would be 32 over 2, which is 16. So our final guy must be the one that's not equal to 16. In expanded form, this is 8 times 8, so this is 64. This is the one that did not equal 16. Ask yourself, why do you think they included 8 to the 2nd power as being the one that's not 16? So the reason why is because this is the most common mistake that people make. So a lot of people remember that exponents and multiplication have something to do with each other. So the most common mistake that people will do is they'll see 8 squared and they'll do 8 times 2 is 16. Not right, okay? It's repeated multiplication, so you take that base and it multiplies times itself as many times as the exponent. So this is the right way to do it. Very common mistake though. All right. And for the bottom part of this page, write 3 expressions containing exponents that each expression equals 81. So 81, that's a really common number that you should know right away. That's 9 times 9 is 81. So a number times itself can be written as an exponent, right? So 9 squared is 9 times 9, which is 81. So that's one way. Okay, so what else? Okay, let's see. Will 2 to an exponent get us to 81? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, 64, 128. Now it jumped right over it. So let's see if we could do 3 to a certain power to get to 81. 3 to the second power is 9. 3 to the third power is 27. 3 to the fourth power is, 81. So if you did 3 times 3 times 3 times 3, multiply the first 2, you get 9, multiply the second 2, you get 9, and you can see that you would get 81. Okay. And the final one is a bit of a tricky one. You could also have just written 81 to the first power, basically saying 81 one time itself is 81. So those are your 3. So make sure that you have all of these notes written on your scrap paper or in your notebook, and type in the problems on your digital handouts in MiserMe, and then we'll move on to the next activity.